Hello, welcome back to my bench. Hey guys, how you doing? I say guys because I just checked and a little while ago, and I have 0% female subscribers. Come on, there's got to be some of you that want to get into electronics or are interested out there. Well, whatever. Anyhow, look what we got on the bench today. Something very few of you have probably ever seen. It's a McMartin, or as we say in the business, McMartin. It is a automatic level controller, LR-1009. I could find virtually no information on this thing at all online. However, we'll take a look at it and see what it does. On the front here, we've got expansion control of freeze and continuous, I guess. A release and attack. Sense level, output level. Meter select switch, missing its little silver thingy there. What is that? It has off, expansion, plus 20, plus 10, and 0 for output, and an on-off switch. Mushy on-off switch. Little rocker, probably lit up with a neon bulb inside. This thing is old, folks. And on the back, what do we got? We got a bunch of barrier strips. It has 24 volts DC in. It says 150 milliamps. It has bridge out, line out bridge, ground, line out direct, music in, page, ground. Those look like they're on a relay of some sort. Freeze and sense monitor. Expand range, pot inside, and a limiter release. And then on this side we got page line in, ground, several of them missing, page microphone in, line sense in, ground, and mic sense in. Interesting. It does have a 120 volts AC input and a fuse. Oh, that's really stuck. And the serial number is 389009. Yeah, this thing's been around for a while. I don't remember if I did a video on a McMartin little receiver that they got for listening to SCAs, like they used mostly for the radio reading services. Maybe I did, I don't know. But anyway, so let's open this up and see what it's got inside. I expect it to look exactly like a McMartin inside, because McMartin always looked like McMartin. Here we go. Oop. Tight. Aha! It looks just like a McMartin inside. Okay. They always use this board, this type of board that you can see right through. It's all single-sided. It does have ICs in it. That's interesting. A few transistors, some ICs, some caps, filter caps over here. What are they? Upside down so you can't read them. 50 volts. 1,000 microfarads at 50. 2200 at 35. That's an ITT. This is an IC. I've seen those before. Everything's connected across the back with little Molex type plugs. And what's it got in here for ICs? Let's see. These are 5534 and 5532. So 55, 34, 32, there's another 34, an NE570N. I don't know what that is. I'll have to look it up. An LM339, another 5532, and it's got a couple of relays, K1 and K2 here. Those are probably for these relay outputs on the back. We'll check those out too when we do it. I have not powered this thing on. I have no idea if it works. It has a fuse going across, a fuse here and a fuse going across the switch. Interesting. So that would be off. Okay, well, we'll see. I got it on the dim bulb, and we'll just turn it on and see what happens. Nothing, of course, since I've got it off. And it did not light up the lamp. It's drawing almost nothing. 100 mils, 11.5 watts. Ooh, that's a lot for something like this. But now we got to check some voltages. Let's see. Always check voltages first. You know my rules. Whoops, wrong one. You got to ground the black one or the electrons get all confused. Lots of grounding spots here. All right, so this says, what, 7824, so a 24-volt regulator. And let's bring up the Vichy. There we go. And my in, 28 volts, 28.25. And my out, 24.06. Well, that works. Check here, 30 volts and 28 volts. Okay, so let's look at one of our 5532s. We'll check the voltage on there. Got 23 volts on pin 8 and ground on pin 4. So it does not have dual power supply, just a single power supply. Alright, so what is it, 11 and 4 for this LM339, so that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Okay, I'll have to look it up. But first I want to go see what this NE570 is. Hang on, I'll be right back. Okay, well, I looked it up and found what this is. Bring it up on the old screen here. And it is a compander. It says the NE570 is a versatile low-cost dual-gain control circuit in which either channel may be used as a dynamic range compressor or expander. Each channel has full-wave rectifier to detect the average value of the signal, a linearized temperature-compensated variable gain cell, and an operational amplifier. The NE570 is well suited for use in cellular radio, radio communication systems, modems, telephones, and satellite broadcast and receive audio systems. Interesting. So if we look here, it has AG cell in with a variable gain and rectifier input and an output, inverted output. So, what's its voltage? 13 in ground. So we go to pin 13. 9, 10, 11, 12, 13. Like I said, mushy switch. Pin 13's got 23 volts on it. Okay, well, take a look at the Typical test circuit here. Got 22 microfarads going into it. 3 and 14, 2 and 15, yeah, because there's 2 of these. And 7 and 10 are outputs. Interesting. Electronic gain control circuit. Not messed with one of those before. Well, let's take a look and see what my how dirty the power supply is. Probably not, because these voltage regulators will get rid of a whole lot, but we're going to see what it looks like on the caps. So, bring up the scope, go across the cap, and get rid of channel 1 because we don't need it, and why not showing much of anything? Okay, let's definitely ground. So try this one. A little harder to get to. Quite a bit harder to get to. Oh, for crying out loud. Let's see. It's clean also. Well, I'm kind of surprised a little bit that those are clean. Alright, well, turn it all off. Check the voltage. Nothing. We'll check for ESR, just because we always do. 0.14, that's good. 0.03, okay. This one, 0.2. This was 0.19. So far, they're looking pretty good. I'm kind of surprised. 0.54. 0.67. 0.6. Wow. 2.1, but that's only a 1 microfarad, I guess. Let's see. 0.2. There's a bad one. Or it's in series with something. 3. 0.68. 2.1. So far, they all look good except for this one. Problem with this is, let's see, here's a big old 0.12 for that guy. That's a one of those, yeah, dips. Probably 2.5. That's probably good. Probably can't read that one. Some of these you can't read because they're across things. 3.7, that's fine. That's too small. Alright, well, we're going to have to... Taking this board out of here is going to be a problem. So I'm going to cut that guy and measure him. probably okay considering all the other ones in here are just fine. No, by George, it's not. That one is definitely reading high. Let's find out, shall we? Okay. Red. And black. All right. This one will read a little higher. That thing won't go very high, and it says 68 picofarads. So it's just no good at all. Interesting. Unfortunately, like I said, I don't have a schematic, so I have no idea where that goes. I suppose I could look at it a little carefuler. Carefuler? Okay, so this thing is a 2.2 at 50. So we're going to have to find some way to stick one of those. I did trace it out a little bit, and it appears to come from down here someplace, and goes right to the mic sense, one side of the mic sense pot. Not the center, but one side. So that means that it probably not going to be working, considering there's not a capacitor anymore. All right. Let's see if we could hook some sort of audio up to this thing. Hang on, and I'll get out some stuff. Okay, well, I got some goes in and goes out of here, but first of all, before we do anything, I got to go into the mic in. We got to strap something across this just to get it to work a little bit. Negative goes to this side. Yeah. I'm just tacking this in here. All right. Nope. Missed it completely. Come on. Cool down. Thank you. That's not a good joint, but we'll let it go with that. All right, so we got that going through. Mic in. Now, let us see if we got anything here. I'm going to say that 5532 back here is the mic preamp. And I got to take this off of here and go up to this guy. All right, here we go. All right, so I finally got this thing figured out. Considering I can't find any information on it anywhere. I did find out that that it is there's two places it's mentioned in a couple of magazines. One of them was the trains from New York City, and kind of by guessing along there, I figured out what this thing is for. What it is, you put this in a rack. You feed either the line input sense, or the mic input sense, with ambient background noise. Like, for instance, if you were in a train station, you'd put this thing in there, and you'd have a bunch of noise out there, and you'd put a mic out there and feed the mic into the input over here, the sense, and the sense would, depending on how high or low it would go, would measure what that is and make sure that when your voice, where you use the microphone input on the back here, not the sense, but the input, when you use the microphone input, that your voice is going to be louder than the ambient noise out there. So if you're announcing trains or something like that, you'd be heard over the ambient noise. It took me a little while to figure out how to hook this thing up, but here's what I've got now. I've got the function generator is putting about a 0.5 volt into the line-in sense. I'm not using the mic because I don't have a setup for that, but I'm using the line-in sense. The line-in is coming from my other oscillator, my little 204B Hewlett-Packard oscillator, and I got it set up at about, I don't know, pretty low line level input. I don't know exactly what it is, but it's there. I'm running this thing off of 24 volts DC because it's just easier to mess around with it. I did change this little cap down here that we found earlier. That cap is just dead open, and everything else in it tests good as far as parts go. All of the other caps are great. These little guys down here are relays, so if you've got this thing turned off, it'll just go straight through. So what happens is, let's pretend that my line in coming from my Hewlett-Packard signal generator is background music or whatever, and the sense is coming in from a microphone or something going into a mic preamplifier and coming into the line-in sense. So what we got, let's hang on, let me get this thing set up so I can show you. Okay, I got my Droid Cam running. We'll bring that up here, and we'll look at the meter on the front of this thing. Right now I've got it set at off. There's a off, expansion, and output level of +20, +10, and 0. So if I put this on expansion, you see that I have an expansion level there. If I adjust the sense level, we can watch the expansion go down. It's pretty slow. I don't know what the attack is set to, but it's right there on the hairy edge for expansion. Now, if I go to output level, I got nothing. So let's say that I want to get the background music, which is coming out just a tone, 1000 hertz tone coming out of my HP. All you got to do is, come on, focus. You take this back here and pretend that this is my switch, and you hit the little, you short out from here to here. And when you short out from here to here, you have a level output. Come on, focus. You have a level output. Right now I got it set to 0 level output. So you'd have a switch in there. You want the background music to play. This switch, you'd turn it on and it would come out. Now, let's look at the scope and see what that does. All right, so what we're going to do is I've got my input sense going into line sense over here. Let's get rid of this for right now. I got my sense going in here. I've got my line input going in here. We're going to pretend that this line input is, music, background music or something. I'm going to the direct output of this system, and I've got it turned on with this little jumper back here. So what I want you to watch is, I want you to watch the scope. And you'll see right now I haven't got much of anything. Just a little tiny bit of noise or whatever. That's because I have my input sense turned all the way down to minimum sense at all. Now watch what happens. This is the output that you're seeing on the scope. When I turn my input sense up to sense the background noise, which is over here coming in, right now at 0.3 volts, if I bring that sense up, watch the output. When I start getting any kind of sense, look at the output go up. So basically what it's saying is I'm going to put this much, whatever that much is, output out of the output over here because there's almost no input. If I bring, or input sense, if I bring that input sense up a little bit until it starts doing expansion, which it's going to start doing here just a little bit, it's going to force the output higher to make up for the input noise, the sense noise. I hope that makes sense. I think it makes sense. That's me with the output level. Let's try that again. I'll take that level, the input sense level, all the way down to nothing. So my background output, let's take it up so that we can basically see it here. Okay. So my output is very low because it doesn't need to be very loud because there's no input sense back here. Now let's pretend that it got louder, and by turning up my input sense, I'm going to sense more of the ambient noise coming into this, and it's going to start going into expansion. When it goes into expansion, the output goes up, way up in this case. Wow. 200 millivolts, it's like 2.4 volts peak to peak. So the output's going to go way up to make up for the fact that it's sensing more input noise, background noise. So that's what this thing is. And has anybody ever seen one of these things? I haven't. I mean, it's like, it's not radio. It's for out there in wherever land, where you've got a background noise in a big building or something, and people are yelling, screaming, hollering, walking, whatever, and you want to announce something, and you want to play background music, and you want them to be able to hear it, or page, and you want to, page announcements, and you want them to be able to hear it over whatever noise is currently in the building. Interesting. I've never seen one. Has anybody else ever seen one of these? Let me know down in the comments. I'd really be interested. And does anybody want this? Anybody got a use for it? Because I don't. It's really quiet in here. All right, guys, there you go. A very interesting, very old, weird piece of equipment by McMartin that still works. One bad capacitor in here, and everything else is just perfect. I mean, it works just great. So, anyhow, hey, thanks for coming, guys. Don't forget to go down and subscribe and ring the bell if you want to see when I'm doing more of this crazy stuff. Thanks for stopping by. Till next time.